All right. Welcome, everyone, to STG409, Building Resilience Against Ransomware with AWS Backup. I am Palak Desai. I'm a Senior Manager with Product with AWS. Joining me is Sabit. Sabit, why don't you go introduce yourself?
Hello, everybody. My name is Sabit Venkarajalpati. I'm a worldwide solutions architect, part of the AWS Backup team. I work with customers globally to help them build recovery resilience using AWS Backup. Welcome again.
All right, so before we begin, let's cover some housekeeping items. This is a 400-level session, so we are going to go through the basic concepts, then dive deep into architecture. So we'll talk through how you can use some of the capabilities to make your environment cyber resilient, and then Sabit will show a demo. I know you all want to go ahead and click a lot of pictures, but there are many build-outs in the slides. So when you see the icon, the camera icon, that is when all the build-outs are complete, and you can go ahead and take that picture. Now, after the housekeeping items, let's get started. The key to cyber resilience is to have a robust plan in place to recover quickly and to minimize the impact of any cyber events. The malware and ransomware events within your environments are progressing from becoming possible to probable, and you need to be prepared to recover from any such incidents. The key to recovery is to ensure that you have your plans in place so that you can recover efficiently when such an event happens. In this session, we are going to cover many capabilities that you can utilize within your environments to ensure swift recovery of your business operations, minimize downtime, minimize data loss, and recover efficiently from any such ransomware event. So let's get started. In this session, we are going to cover in great detail the cyber threat landscape. We'll walk over what situations there can be for a cyber threat. We'll talk about the role of backups. We'll talk about why backups are important to make your environment cyber resilient. We'll talk about backup strategies. So there are many different ways and means that you can utilize to ensure that your environments are protected. We'll introduce a capability that AWS provides, which is AWS Backup, and how that can help you secure your environments. We'll talk about recovery strategies. We'll also have a demo at the end, and then we'll summarize our key learnings. Now, let's walk through a scenario. It's Monday morning. You get an email. It's an innocent email. It's looking very legit, right? And there is a link in it, and you click on the link. And that begins the onset of your ransomware event within your environment. There is malware that gets downloaded within your environments, and it is dormant. You do not really realize what's happening, but it is something that's spreading within your environments. And as time passes by, it spreads more and more within your network, within your data, and with increasing threat levels. So that is the sort of the first phase of your ransomware event. Then you suddenly realize that there is a major encryption event that happens within your environment, and you realize that there is a threat that has been progressing within your environment for many, many days. Your data, your cloud storage, your databases are all encrypted. Your backups may be deleted, or the access to the backups may be revoked. At this point in time, you have an option. You can either pay up the ransomware or try to recover from outdated backups. None of these options are great because now we are going to go ahead and realize downtime in business and take a risk to your reputation and have financial punishments onto your business. So what do? The idea here is to ensure that you have a recovery plan in place. You can think through your backups. You can swiftly detect that there is a ransomware event happening within your environment. You isolate that event that's happening, and then you go on to a swift recovery using your backups, which are sitting in a logically isolated environment, so that you can bring your business online again. You can make your business viable again. Ransomware just does not affect data. I mean, of course, there is data loss, but it affects your business. It affects your reputation, right? And you want to minimize that time that is required to recover in such an event. The only difference between making this event a catastrophe for your business versus just a minimal glitch within your business is your preparedness, is how quickly you can recover from such an incident. And that is what we will talk about today in this session. So let's walk through some timelines. Say there is a threat that you detected within your environment. Research shows that any malware or any ransomware within your environment is actually dormant and spreading quietly within your environment for upwards of 200 plus days to a year. So really the threat happened many, many months back and you realized it then. So once you realize that there is a threat, there is ransomware within your environments, you quickly go to understand the impact, the reach of that ransomware within your environment. So that takes a couple of hours to a day. Once the threat is detected, you get into mitigation phase. So you launch an incident response. You then go ahead and talk to your insurers. You do forensic analysis. And that in itself will take anywhere between 5 to 14 days. After that, you launch your recovery mechanisms. So you try to recover from the backups that you have so that you can bring your business back to normal. And finally, within 1 to 3 months, your applications are online. Your business is up and running. You're able to fulfill the needs of your end customers. So the key point here is there is this metric, which is mean time to normal. And mean time to normal means your business is viable again within that time frame after an incident has happened within your environments. You need to work towards ensuring that the mean time to normal is reduced because that is what will effectively protect your data against compromise, protect your business against compromise, and ensure that you do not have loss of reputation or any financial loss. We need to work towards strategies that will help you achieve a recovery sooner rather than later. So it's very, very key that you focus on the mean time to normal and try to reduce that time as much as possible. So let's talk about some trends and threats. There is a persistent threat landscape and it's ever evolving, meaning all businesses, small and large, are vulnerable and can experience a ransomware event. But when that event happens, we need to ensure that organizationally you are aligned, meaning your cyber threat teams, your security teams need to talk to your data teams, need to talk to your backup teams, and procedures need to be put in place that from the instance that you realize that there is a threat within your environment, there is an incident within your environment, it's go time. You know exactly what needs to happen. You know exactly where is the data that's resident and how can you recover quickly. The threat is just not loss of data. I mean, it's an entire financial impact that you may have to think through because you are losing business at that point in time. You're losing reputation at that point in time. And you may also incur certain regulatory pressures if something like that happens. The threat is getting more and more sophisticated. So initially, only primary data used to get targeted. Now, even backup systems are getting targeted. So you need to think through your backup strategy in detail so that when such an incident happens within your environment, you know how you can cleanly recover from your logically isolated backups. And of course, there is evolving regulatory landscape. So there are many regulations. We'll look through those on the next slide. That is mandating that you secure your environments and you provide cyber resiliency in case of a ransomware event. We're not going to go through this slide in detail, but essentially these are some of the regulations, and I'm just going to build it out, that do mandate that you're doing ongoing testing, you're ensuring that your backups are secure, you're doing ongoing compliance, auditing, and monitoring of your recovery systems so that you can ensure that when such an event happens, you are covered. And there is minimalistic downtime to your business and minimalistic financial impact. All right. Keeping this in the backdrop, I know Sabith has worked with many customers to ensure that their environments are cyber resilient. He will walk through the role of backups and how backup systems get targeted and what you can do to ensure that your systems are protected.
Thank you, Palak. So now that we've had a closer look, or at least a higher level look at what the cyber threat landscape has been, and then we also saw a summary of like a couple of surveys that was done across our customers. Let's see what the role of backups is in mitigating the risk that we talked about. So the essential point here is to ensure that you have got a way of recovering from any of these cyber events. So whenever these cyber events happens, like the essential point here is to minimize the mean time to normal, and then your business impact is like reduced as much as possible. So when it comes to defending against ransomware, the key comes in the recoverability of your data. So it's not just about taking backups for the sake of taking it, but ensuring that they are indeed recoverable and then available for you. The first and foremost important step in understanding the larger picture is to identify what exactly that you're trying to achieve. This is where we would like to apply the concept of threat modeling in the recovery resilience. So basic threat modeling, when you apply the concept of a threat modeling using a basic 4-question framework, what you're trying to do is to understand what exactly are you trying to build. So in this case, we are trying to build a resilient recovery strategy, and then you obviously ask the second question. In that resilient recovery strategy, what all things could go wrong? What are the threat vectors that you're kind of wanting to protect against? And the third question that you would ask after identifying all the threats is to understand what are the mitigation strategies that you're trying to put. So you might have a couple of threats that you've identified, you might have mitigation strategy for each of the threat, and if you don't have a mitigation strategy, you probably will capture that in your risk register and say that, okay, I kind of agree to the risk, but I somehow don't have a mitigation strategy for it. And much like any other plans, you have to always look for a continuous improvement. So you kind of keep asking this one so that you could adapt for the evolving threat landscape. And when you capture these things in what we call a threat model document, that's where you've laid the foundation for all this recovery resilience in place, because the key of it is understanding what you're trying to achieve. Because if you don't know exactly what you're trying to achieve, you might end up just going to backing up all of your infrastructure. And then the primary concern then would be cost, without even understanding why you effectively started doing all these things. So when you start doing a threat modeling initiative in a systematic way, you would understand exactly what's the landscape that you're trying to work against. Let's talk about some of the strategies for securing your backups. So there is an industry standard approach called the 3211 approach, in which we kind of talk about 3 different copies of your data. So these 3 different copies can ideally mean 1 production data and 2 backup copies, or you could even go with 3 different copies of your backup production data itself. It is always recommended that at least 2 of these backups are kept across logical boundaries. And in the cloud native space, we kind of talk about keeping them across account boundaries. So you have a primary backup data in your local account, and the second backup copy resides in a separate account in your AWS organization. And one of these backup copies is recommended to be kept in a different region. And this is primarily to cater against all these regional resiliency requirements. So if you have got a data residency requirements in which backups cannot be copied across regions, then probably this does not apply to you. But if you've got a requirement of like in recovering from a regional failure, which obviously you have to plan for, even if how much ever unforeseen it would be. And then the final point of one would be to ensure out of all the 2 different copies that we talked about, at least one of them has to be in an immutable backup vault. The intention of keeping them in an immutable vault is to make sure that, whenever the compromiser would want to go, not just compromise your production data, but also try to compromise your backups, they can't do that because it's in an immutable vault. But the most important aspect of all this strategy is the number 0 here, which ensure that you're not just taking backups, but you're ensuring that these backups are indeed recoverable and available for you to restore whenever there's a situation that you're trying to respond to. And this 0 is what a lot of the regulations that you saw in the previous slide are trying to allude it to, which in regulations like DORA or NYDFS, which is in the FSI space, or even regulations like HIPAA, or even things like GDPR kind of talks about ensuring that your data is not just protected, but they are also available to restore on the unforeseen situations. So now let's take a scenario-based understanding of why is it important to secure your backups. And this is again a sample scenario. This is not a recommendation from our side. So just for ensuring that I can capture all these things in a single slide, envision a 14-day retention period of your backups, and you're doing daily backups. And you've been taking backups for, let's say, the first 7 days. All these backups are clean. You've kind of tested them somehow and all these things. They're all clean. It's fine. And imagine there's an event that happened during the 7-day period. You could always use these backups to do a recovery. It's all safe period that we can talk about. And then envision a situation where most of your endpoint detection systems kind of tripped and then allowed a malware to somehow come into your production data. Because you're backing up the production data, your backups will also have a copy of the malware being replicated into the backups. So these backups are kind of infected with malware, but not really compromised. So it is between a compromise and an actual good data kind of thing. This situation or the period of backup numbers 8, 9, and 10 is still a safe period provided your backup scanning softwares can exactly pinpoint where the vulnerability is. This is like in a situation where you know exactly, for example, a virus.exe is in your EBS snapshot, and you could safely detonate, safely and like restore them into a controlled environment and kind of remove only that particular infection and then try to restore that. So your RPO is not kind of compromised that much. It's still a safe period to do. But the ransomware event actually happened, and there was an encryption event that kind of happened in your production data, which means that all of your backup copies also will be having the encryption. This is the situation or the time period where all of your recovery options are depleted, in which if you want to restore, you would not want to restore from any of the backups numbered 11 to 14, because you're just going to re-allow the malware to be getting back into your environment. So even in this space, you don't even have an option of like doing a controlled restore and then try to recover from it. So the point here is that whenever you try to come up with your backup strategies, you have to be very careful about how often do you backup, how long you're keeping your backups, and most importantly, how often do you test for the presence of any of these compromises in your data. So in this scenario, if we could not find out the vulnerability within that 14-day period, what would have happened is that all of your last good known backups might have deleted, lifecycled out, and you might end up only having compromised backups from which even if you initiate a restore, it's not going to help your environments. So that's a key point here. So now that we understood the threat landscape, the importance of backups and all these things, let's go deeper into and then understand how do we implement effective backup strategies. Before we even talk about backup strategies, one of the important concepts that I would wanted to introduce is data vaults or backup vaults. So backup vaults or data vaults is nothing but a logical container of your backups so that you can group and manage them as a single entity. So imagine in your organization you have got data classification requirements to term your data, something like platinum data, gold, silver, and bronze. You might end up having data vaults created based on the data classification, so that you can have not just encryption strategies, but also data access strategies that applied at the data vault level. So you might have only privileged users being able to access backups of platinum data, and anything that is like plastic or bronze might not be accessed by only the lower privileged users kind of thing. So the backup vault is actually the important concept that you would have to get to before thinking about implementing any of these strategies. And how do we use these backup vaults? The first and foremost step in making sure that you have a proper backup strategy in place to understand what you need to back up. So we kind of did the threat modeling document to analyze what are the threats that could hamper your recovery. But even the next step ideally then would be to understand what needs to be vaulted. So this is where your data classification, your recoverability, and all these things comes into place, because you might not want to back up a data that could be restored from an existing data. Recreated from an existing data. For example, if you've got a data lake in place with a pipeline bringing in raw data, and if you've got a process data, you probably might not even want to back up your process data because you're confident that you could recreate that using a little bit of compute from the process raw data. But it also depends on the time that is taken to recreate that process data from your raw data. If that recreation of the process data from the raw data is critical in your organization, you might end up backing up the process data as well. But the point is to understand as an organization what all you would want to be backing up. This is the second point that I was previously mentioning, where you have to understand the partitioning methodologies of your vaults, so that you would clearly classify the access control and then storage mechanisms of your vault. So you don't want to be combining your platinum data with the plastic data or the bronze and silver data kind of thing. So that kind of allows you to prepare a better strategy. The third important aspect is obviously the management access of the vault. Who have got access to these backups? While backups is not the primary method of exfiltrating data, it can also be another way of exfiltration of data. If you don't have proper controls in place as to decide who can restore from a particular vault, who can copy the data from a vault and all those things, then you probably might end up allowing exfiltration of the data, which probably might be happening through a lesser monitored environment kind of thing. And on top of all of these things, the most important aspect is how do you recover? So the previous situation of a cyber event happening in your environment will always go through an initial phase of deciding where to recover from. So this is what we call the DTO, decision time objective. So in the DTO phase, if you're hit with a cyber event, you have to first understand what are your recovery options and what is a recovery path you would be wanting to take. Whether you would want to recover from your primary backup or you want to recover from your copied backup and all those things. So after the DTO is done, your recovery will be varying depending on where you try to recover from. So if you're recovering from a copy, probably there's an additional step of wanting to copy that data back into your production environment and then try to restore from there. So that's why how the recovery would look like is more critical as well. But on top of all these things, there's other important components to this one, which is nothing but the understanding about all the components involved, what are the software and service providers involved, are you using a managed service provider like AWS Backup, or using a third-party backup provider or things like that, and what are the people and process involved in this one, do you know all the roles and responsibility in the recovery process. And obviously on top of all of these things, the organization's sponsorship is very critical, and if they don't understand the criticality of ensuring a cyber resilient setup in place, probably everything else is flawed from beginning. The other concept that we wanted to talk about in this entire backup strategy is the maturity level. Obviously, every customer of ours want to start small and as fast as possible. So we would ideally start with the baseline approach wherein you would be doing automated scheduled backups, which is aligned to your RPO requirements, and that's it. But the most important thing is that whenever you go through an analysis paralysis kind of a situation, and if you don't implement any backup strategies, there's a larger risk window in which if there is a cyber event happening, you don't have any options to recover from. This is what we would want to avoid. But it is always possible for you to iterate from the initial baseline approach and then add more capabilities to it. And obviously you would want to not migrate, obviously proceed from a baseline approach into an advanced approach where we talked about things like logical isolation of your backups, protecting your backups, like management structure to be brought into your entire AWS organization and all those things. Then we could always go to the ultimate state of advanced plus where we implement things like automated restore testing, extended forensics, where we talked about scanning your backups for any presence of malware or ransomware and all those things. And we could be thinking about restore orchestration, where you could automate all of your recovery using a single click experience and all those things. So the point here is that you have to, So the point was, you don't have to be starting from a very advanced plus on day one. You could always start with a baseline approach and then progress through an advanced and an advanced plus. And to talk more about what AWS has in offering, I'll ask Palak to.
Thank you, Sabath. So now we know that backups are important, right? And at AWS, we have AWS Backup. It's a centralized mechanism which is policy-based that makes it easier for you to take backups across a variety of AWS resources, starting from your compute to your storage, to your filers, to your databases, and also certain on-premises resources such as VMware and SAP HANA. Through that AWS Backup, it gives you the ability to schedule your backups, incremental or continuous, on an ongoing basis, decide what your RPO is, and based on the schedule the backup plan would run, it will take your backups on an ongoing basis and vault it as it creates. So it's a fully automated policy-driven system that you can implement within your environments to take backups on a periodic basis.
So Palak, what are the very specific capabilities that we are building on cyber resilience?
Absolutely, right? So we heard Sabit talk about vaulting and the importance of vaulting. Recently, we GA'd a capability which is known as AWS Backup Logically Air-Gapped Vault. What it gives you is the ability to provide isolation. So think of it as a service-managed account where your backups reside using service-managed encryption so that there is no ability for that malware or ransomware to go ahead and encrypt your backups because it's sitting in a service-owned account with service-owned encryption. And it's highly available because it now provides an ability to share your backups using RAM-based sharing into a newly created account in case of a ransomware recovery. Right? This gives you peace of mind that your backups are immutable and they are secure from any event that's happening within your environment.
So how do you validate these backups then?
Yes. So as the saying goes, backups are only as good as their restorability, right? So when you want to think through a ransomware incident, what you want to really think through is how do I recover and how do I recover quickly, right? So you need to go ahead and test the recoverability of your backups on an ongoing basis. For that reason, we launched a functionality last year, which is known as AWS Backup Restore Testing. It gives you the ability to test your resources in an automated fashion on an ongoing basis. Just like a backup plan, you can create a restore testing plan, and you can specify the resources that you want to restore test, the frequency at which you want to restore test, and the time duration where the restore resources should live, right? So once you specify that, the restore plan will run, it will restore your resources. You then have the allocated time to do more application-oriented testing on those resources, so you can be prepared in case you need to really recover an application, and then the automation would tear it down for you.
I think this is the most critical component of all the regulations that calls out like validation of your backups, isn't it? But how do you ensure this reporting aspect of?
Right, so we got you covered there as well. We have launched AWS Backup Audit Manager. So one is taking backups, second is testing through the restorability, and the third is auditing and compliance, right? You want to prove to your regulators that you are, in fact, sending your backups to a logically air-gapped vault. You're restore testing them on an ongoing basis. You're securing your most critical resources through backups, so on and so forth. So in Backup Audit Manager, you can define your compliance, and the report runs against your compliance criteria. And then it will generate a nice report for you so that you can now see what is happening within your environments, and you can prove to the regulators that you're in fact taking the necessary steps to make your environment cyber resilient. With this, now I know a picture is 1,000 words, slides are great, but let's dive deep into the reference architecture. Sabat?
Yeah, thank you, Palak. I'm safely assuming that like everybody understood what the importance of backups are, like how to implement strategies and all those things. What we're going to do now is to look at all these concepts that we discussed until now and apply into a reference architecture. And the word reference is actually very critical here. This is actually a reference architecture, which means that this might apply to you in whole, or it might apply to you in parts. Like it all depends on the threat modeling exercise that we talked about previously. So envision an AWS cloud environment in which you have an AWS organization set up. What we would want to ideally start with is what in the concept of backup delegated admin accounts. I'm safely assuming that everybody knew that this was a capability that we launched a couple of years back, in which we wanted customers to follow the principles of least privilege and then have backup admins in your organization perform backup administratory activities in a separate account in your AWS organization so that you don't have to give management access to them. So we provisioned what we call a delegated admin account in which you can create backup policies. So backup policies is an opportunity for you to work backwards from your data protection strategies, which you would have created by now, and to define things like what are the resources that you would want to back up, how often do you want to back up, how many copies of these backups have to be kept, and all those things. And when you apply these backup policies into your organization, you've got AWS Backup automatically creating the backups for you. The other important concept that we brought in this reference architecture is what we call the key vault account. One of the common threat vectors that we have seen in a lot of the customer environments is the notion of losing access to your CMKs, customer managed keys. So if you ever use customer managed keys to encrypt your data at rest, there could be a compromised situation of these CMKs being maliciously deleted. Even if you get an opportunity of only being able to schedule the keys for deletion and then a minimum of 7 days before it will be actually deleted, there could be a situation where you might end up losing the keys because you did not get to the actual alerts in time and all those things. So what we kind of recommended our customers is to provision what we call a key vault account in your AWS organization and provision your CMKs and then have them shared across your workload accounts so that they could be utilized in them. The advantage is that you are now applying the principles of defense in depth so that the management and maintenance of the keys is the responsibility of a different account. And the advantage here is not just the security aspect of it, there's also cost benefits of it. So if you're running thousands of accounts in your AWS organization and if you end up provisioning thousands of CMKs, you are now bound to pay for that particular CMKs that you provision. So rather, you might be able to provision keys based on your data classification requirements and have them created in the key vault account and shared with the workload accounts. Then we also introduce the concept of what we call the data bunker account, which is ideally aligned to the logical isolation that we talked about previously. So if you were to be wanting to mitigate against the threat of your original account being compromised, it is always advisable to have a copy of your backup in a separate bunker account, which follows the principles of defense in depth to ensure they are all like kind of secured. So the bunker account here is actually in the same region where your workloads are running. Then we also recommended a break glass workflow to be applied for access for your bunker account. This is ideally to ensure the bunker account is only a storage only account, not an operational account. So any operational access to the bunker account has to go through a break glass workflow, which is well documented using AWS best practices. Now let's look at all of your workload accounts. These are production workload accounts in which you will be running your production data. Because you have applied the backup policies which were created in delegated admin account into the workload accounts, there will be local backup happening on a regular basis, which is the undifferentiated heavy lifting that AWS Backup does for you. This is your first copy of the data. Now, you can also have a plan, a rule in place which will copy the backups from the local vault into the bunker account. And this could be done in a staggered approach. So depending on the RPO requirements that you have for the local account backup, which might be a bit more stricter in terms of like probably an hourly RPO, you might end up copying only the daily backup into the bunker account. So that way you can have a balance between your cost and benefit as well. This is the second copy that we talked about in the 3-2-1-1 approach. And if you've got regional resiliency requirements, you can now do a third copy, which will be sent into the bunker account, set up using the similar principles in a different region. So what we kind of recommend our customers is to understand your RPO requirements. So the first copy that you have in a workload account might be catering to your operational recovery requirements. So you have a stricter aggressive RPO will be 1 hour in nature. And you have a copy in your bunker account in a different region, probably catering to your regional resiliency requirements. You might have a lesser RPO on this one, lesser aggressive RPO, probably a weekly copy that is sent to the bunker account in the other region. For cyber resiliency purposes, you keep a copy in the bunker account in the same region that would probably have a cyber RPO of 1 day. So that way you will be able to control the cost and benefits on this one. That's not all of it. What we also recommended our customers is that you should ideally think about having a separate forensic account in your entire AWS organization so that the validation of your backups can be done independently in an isolated account. And why do we recommend a separate forensic account? One, you could always have proper access control mechanisms put in place so that the data that is residing in the bunker account on the workload account does not need to be shared directly with a separate team, like the threat hunting team, which would want to find out how even the malicious threat came into your account. So if you were to find something during your restore testing, you would not want like the copies of the data residing in the bunker or workload account shared with that forensic team. So again, this is a reference architecture. We do have customers who implement this in its entirety. We do have customers implementing this in partial stuff. We do have customers implementing only the local copies. It finally boils down to the any threat modeling exercise that we talked about previously. You have to understand the threats that you will compromise your recoverability and the mitigation strategies. And this is just a summary of all the mitigation strategies that you can apply in a single slide. Now let's double click on this forensic account so that like we can go deeper into what capabilities does AWS Backup provide in this scenario. So we talked about the entire operational aspect of having a workload account and a vault account and all these things, and then you have copies of your data being sent to vault account. And we are actually envisioning a logically AGAP vault in this vault account so that it can receive copies of the backup coming from your workload account. So like the forensic account that we talked about in the previous slide, if you're provisioning a separate account, what would happen is that you're now configuring AWS Backup restore testing. Much like how you work backwards from your data protection requirements using a backup plan, you can use a restore testing plan to define how often your testing has to be conducted on what resources. And these AWS Backup restore testing is actually tightly integrated with AWS Backup Audit Manager, which means that all of the jobs that you're running using restore testing can be well audited and validated using the controls within AWS Backup Audit Manager. Now let's use the capability of AWS Backup Logically AGAP Vault to create a resource access manager share and have it present to the forensic account. Previously, customers were required to do a copy of the data, deep in nature, from the Vault account into the forensic account before you could do the testing. But with AWS Backup Restore Testing's integration, seamless integration with the logical air gap vault, you can operate the restore testing on a share. So with the share, what would happen is that AWS Backup Restore Testing will create what we call the temporary restore resources. This is an opportunity for you to understand what is the bare minimum RTO that is required to restore your resources. So if your EBS volume of 1 terabyte takes 1 minute to restore, you know that's the bare minimum that you can build your recovery workflows on top of it. But that's not all of it. You would get an event bridge notification whenever your restore jobs is done, whether it's a normal restore job or a restore tested restore job. You kind of can have a custom Lambda function that will be invoked on the completion of the restore job. And with our partners solution from elastio.com, you could have it initiate a scan on your temporary resources. So the advantage here is that you would be able to now do 2 different passes of your validations on the restored data, whether it's an EFS volume, FSX volume, S3 buckets, or EBS volumes. You would be able to do malware and ransomware scanning on this one. But once the scan is done by Elastio, they would be sending you a notification through an event bridge, for which you can either decide to have it stored directly in Security Hub or have it notified through the restore validation Lambda that we had previously. But the main advantage is that AWS Backup now provides you a new API called put restore validation status. You would now be able to update the status of the restore testing in your recovery point, which will initiate the cleanup of your resources. The major advantage here is that you are now able to go through the entire lineage of backups and figure out which was restore tested and what is the status of the restore testing. That way, whenever there's a cyber event that you're trying to respond to, you know what is the backup that you can go back and then confidently try to restore from. Okay, now that we have talked enough about the threat landscape, importance of backup strategies, like how to use AWS Backup to implement all these recovery strategies and all these things, envision a simple scenario. I'm sure you all might be going through this one. It's a Friday evening, you've done with all of your job, you get your favorite drink in your hand, you get to your couch and then like try to put the favorite movie and get to watch it, and you just suddenly glance upwards and then see there's a leakage in your roof kind of thing, and you see the starting of the leakage kind of thing. But what would go through your mind is the things that would have been going behind the scenes, like you just want to analyze the impact of the leak by just seeing the breadth of the water that you see in the roof and all those things. You kind of want to analyze all the risks that is going through, like is it going to cave in, like do I have to call the plumber, it's a Saturday tomorrow, like you might be going through all these thoughts so on. Much like this similar situation, if you're going through a cyber event, what you would want to do is to have all these plans in place. You don't want to be thinking through what you're going to do whenever such an event happens, like be it a leak in your roof or be it a cyber event that you're trying to respond to. So the point is that whenever you're trying to plan for a successful recovery, you need to have a proper plan in place. What we have talked about until now is the strategies of creating proper backups, creating the proper foundation for you to be able to recover from. But that recovery itself is actually a different kind of planning that you have to create, which is independent of the backups that you created previously. So obviously, it all starts with a risk assessment. Much like any other process, you have to understand what you're trying to respond to and how do you respond to. And there would be data protection and backup strategies. So this is the place where your recovery strategies and your backup strategies have to be aligned, which is the organization disconnect that Palak was talking about in one of the previous slides. So this is in an assumption that all of your teams which is responding to a cyber event is all aligned in terms of what they would recover from, what they have already backed up into. Then you would plug those strategies into your incident response and recovery procedures, which means that you know exactly how to recover from each and every of these backups that you have already created. And there's always a lot of collaboration and coordination that is required between all of your teams, which means that you know exactly what is the communication channels and how do you respond to all of these things. The most important aspect of all of these things is testing and training. You have to continuously evaluate the process to ensure that these are indeed battle tested all the time, which is what all the regulators across the globe kind of want you to do. Some of them kind of enforce it, some of them kind of recommend that you would be doing testing of all of your restorability. Then much like any other plan, you need to have a continuous improvement in place, which means that you continuously look at the strategy and then try to make it better, which is an iteration that we talked about. And again, there's also a concept of a maturity model in this recovery planning, which is what every organization will go through. You always iterate and make it better. Okay, so now that we looked at the importance of planning, let's envision that you have been hit with a cyber situation. You're wanting to initiate the recovery. You start somewhere. You don't recover all of your important business services just like that. There might be a lot of foundational components that is required for your important business services to be made up online. So these are things like your identity providers, your core messaging services, core landing zone services within AWS. You won't be able to provision any of your production workloads without bringing all of these things online, which is what we call the foundation services. Then we kind of go to the next level of recovery, which is obviously the dependent services. In the dependent services, we kind of look at what are the services that is required for your actual important business services to recover. This could be in the form of global database tables that you have to provision, or your messaging services, or your third-party solutions like the CSPMs and all those things that you have to provision. And once you have recovered with those things, you kind of start with the recovery of your important business services, which is what is critical. And most of the time, you don't recover the important business services to its maximum capacity on day one, because you're responding to a cyber event and you want to be playing very safe with your resources. So this is where we call the importance of MVS, which is the minimum viable service that you have to try and recover. And when you do that in different phases of your important business services, this is where you would complete the recovery of what we call the minimum viable company. So the minimum viable company is a set of services that will allow your organization to get back on its feet after a cyber situation. This is also tying back to the earlier point of understanding what you would want to back up. So your backup strategy would be aligned to your minimum viable company. So it is very critical to understand, out of all the 10,000 or 100,000 applications that you manage in your organization, what percentage is constituting the minimum viable company. And if you don't know, it is very hard for you to plan for a proper recovery. Once you've done your minimum viable company recovery, probably the phase one is done. This is where you would probably go and initiate all of your other services. So generally, whenever an organization is responding to a cyber situation, you would want to do it in phases. And the critical point here is that there is always a critical path of recovery. You would not want to parallelly restore all of your services at the same time, which obviously is not possible. Much like AWS have got soft limits on how many parallel restores you can do and all those things, every other environment will have its own limits. So you don't want to be using up all of your limits at the same time. So you would want to properly plan for it and then do it in a staggered approach, so that you can ensure that there's a proper recovery in place. Okay, so now let's get to the most important aspect of which is nothing but the summary. But before handing over to Palak for the summary, I'm going to try and show you a demo of all these things that we talked about. So I'm just going to recap the reference architecture that we talked about earlier, where we have a workload account, a vault account, a forensic account, and a recovery account. I've set up a demo video just to be sure that the demo gods are not going to be crazy on me. Just to be safe as well, I've recorded a video and I'm going to do a voiceover on this one. So let's try it out. Okay. So what you see here is actually the delegated admin account that we talked about previously. So in my delegated admin account, I've got backup policy set up. So I've got two different backup rules. One has got a local backup, and the other one is actually a rule which copies the data into different accounts. So in here, you can see that I've got a target set up for my workload account. So which means that whenever I've got my workload account set up, I would have different backup policies which will be assigned to it. But in this simple example, I've got an OU called workloads in my AWS organization, and this backup policy that I just created in my delegated admin account kind of applied to those OUs. And this is where you would. And this one is where I'm trying to create my key vault account. So in this one, I've provisioned multiple CMKs, and what I'll do is actually I'll make sure that they're kind of shared across different parts of your organization, depending on how you would want to be able to access them in the individual workload accounts. So you can say that they've got access. Okay. So the most important thing with the KMS Key Vault account is that you should have a proper access pattern on how they're shared from the Key Vault account into the workload accounts. So whenever you copy a backup from workload account to the Vault account, as you would already be knowing, the destination account need to have access to decrypt the recovery point as an initial step. So with the introduction of a Key Vault account, those processes will be quite simplified. Then we have got now the workload account, in which you can see that the backup plan policy that I created previously is now available as a read-only plan. It's actually not modifiable by the individual account. So all my workload account will have jobs that's being run using the common minimum backup strategy that I created from my policy. And this is all copy jobs that would be sending the copies into the Vault account kind of thing. So this is also an advantageous thing wherein you can enforce a common minimum backup strategy across your AWS organization. So rather than not waiting for the individual workload owners to be creating proper backups, you are enforcing a backup policy to be creating common minimum backup strategies. But the individual workload owners are free to create additional backup plans locally to create a bit more aggressive backup strategies if they want. But that will be on top of what the organization common minimum policy is setting up. Yeah, so you can see that I've got my gold vault, which is based on the classification of the data. And it also has an access policy in which you can apply resource control policies to say that, okay, who have got access to restore or who have access to copy. Now let's go into the bunker account. In the bunker account, as you can see, I've got a central lag vault which is created, and in which all of the backups that I was previously created in the workload account is getting copied here. And I also have access policies here in this place. So one of the important point to note here is that, in AWS Backup, there is a concept of a data corridor. Like it is nothing but allowing you to define what is the direction in which you will be sending backups. So when you use resource policies on both the source and the destination account, you can define exactly on an individual recovery point which has got tags level to say that, okay, you only allow copy from workload account into Vault account, not the other way around, or even to stop all the exfiltration of the backups from happening. So this is what we call the data corridors, and then which can be used effectively. And then you can see that lag vault allows sharing of accounts. I've got it shared with what we call a forensic account. You can individually control the shares. You can actually share with different accounts, and you can see that there's a RAM integration in which you will be able to go in and then exactly control all the read-only permissions. So lag vault share is all read-only in nature, which means that the destination account cannot do any destructive operations on the original source data. So I've got my bunker account. You can see that, like in the RAM share, I've got all these permissions, including list tags, which is available on the destination account. So if I now switch back into my forensic account, and if I go to the tab where vault shared with this account, you can see that this particular vault, which is created and residing in the central lag vault, is now available in the forensic account. So previously, I was required to copy the recovery points from the vault account into the forensic account. Now, just by doing a simple sharing from the vault account, I can see the contents of my central vault in the forensic account. So if I click onto the central lag vault, I would now be able to see all the recovery points that's actually residing in the central vault in here. Okay, so, and you can see that it's only read-only permissions that I have on the destination account. Now, if I go into, and the attribute says that, okay, it has been shared with this account, it will also tell you which is the owning account and all those things. So now, if I go into my restore testing console, you can see that, okay, there's a restore testing plan I've created, and there's actually an opportunity of defining a resource-based selection. So I have created one for EBS and another for S3, but you can also see that I've actually chosen to run the restore testing every hour from the lag vault, which is actually shared with this particular account. And I've got opportunities of either selecting the last backup or a random one. So it all depends on your testing strategies as well. And you can see that I've got all my jobs being run here. Oh, sorry, in the resource selection, this is the most important point, where I've got an opportunity to say, retain the resource for a number of hours. This is the time period where AWS Backup will retain the temporary resources. So for 1 hour, we don't delete the temporary resources. this is a window of opportunity for you to spin up any of your downstream validation systems, like the one that we talked about using our partner solution, to be performing validations. So that way, you're not just doing the restore testing, but also the validation of the data integrity as well using this one. And just after 1 hour, or the calling of the API, which is the put validation status, whichever is earlier, will delete the temporary resources. And you can control a few parameters on this one, and we've got IAC support for this one, which means that you can have more granular restore parameters that you can set. And you can see that all of my restore jobs are here. So this is actually a restore job that was done. So you can see there's 3 different status on this one. One is what we call the status of the actual restore itself, which is like whether the restore was successful or not. And the final one is what we call the deletion status, whether AWS Backup was able to delete the temporary resource or not. But the most important point is actually the second status, which is the validation status. And if I go on this one, there is an opportunity. You can see that it says that the recovery point is compromised with 0 malware and 100 ransomware stuff. So this is actually a status that is sent back by Elastio, which is what we are showcasing here. You got an opportunity of updating the message however you would want to do, up to 1024 characters. But this is what decides like whether your testing is successful or not. Okay. This could be the same thing happening for other things, like you can have different validations, so it just shows different one. But there is actually one recovery point in which the testing was all successful. You can see that it's successful. So this would be in your lineage, the last good known backup, which has gone through a restore testing, and the validation all I've gone through successfully. And then, as you can see, that I've got a Lambda function which is showing the demo, which is actually invoked through a restore job completed status. And in this Lambda function, you've got an opportunity of calling the put restore validation, which will be just the update of the status, which is what you would be doing. So you can have a simple Python function to be invoked on top after your restore testing is done, which can call whatever your downstream validations that you would want to do, and then call this API, and everything is done. Okay. Yeah. Okay. Now, Palak, if you could summarize, please.
Thank you for such a great demo. So just summarizing the key concepts that we have learned here. Recovery is key to reduce the mean time to normal. Again, that is the one parameter. If you can shrink it down, it will make the difference between a disaster versus just a minor glitch. Detection often relies on critical mass, meaning you detect after the malware has been within your systems for a long period of time. Backups, and I'm not going to go through this entire thing, but the key thing here is to plan your backup strategy wisely. Not all data is equal. Like Sabit mentioned, you do want to think through your minimum viable company so that you can think through your backup strategy, think through your recovery strategy, and plan accordingly so that when such an incident does happen, you are prepared and you can quickly recover your applications and return to normal. And cyber resiliency is just not a operations problem, but it's really a business problem. It's a financial problem that you do need to tackle. With that, thank you so much for being here with us today. I know you all are hungry, but before you all go, please take a moment to give us feedback, give us a thumbs up on the survey so that we can be here next year presenting to you all. Thank you so much and have a good day.